Welcome back to Educator.com. In this lesson, we're going to take a look at some very special factoring techniques that you want to know. So some of these special factoring techniques will be recognizing the difference of squares, a perfect square trinomial, and the difference and sum of cubes. These are great patterns to pick up on that can cut out a lot of work for you. Recall that when we were multiplying together a few different polynomials, that some very special ones came up. For example, if you multiply these two together, x minus y and x plus y, the middle term ends up dropping out entirely. Let's see. So our first terms here would be an x squared. Our outside terms would be an xy. Inside terms, negative xy. And last terms, negative y squared. So the only thing that really remains, since these two cancel each other out, are just the x squared and the minus y squared. In a few other situations, we might have had, say, x plus y the whole thing squared, and x minus y the whole thing squared of that one. Now, since we've been working with factoring, we really want to look at all three of these processes in the other way. And so if we can recognize that we have one of these types of polynomials, we'll immediately know how it should factor on the other side. So think of these as like some nice handy formulas that can really help you cut down on the factoring process. Now, since we are looking at these in reverse, you really want to look at some key features of these formulas to help you recognize them when looking at those polynomials. Let's start off. When you're looking at the difference of squares, here's how you can pick it out. 1, both of these terms should be squared. And notice how there is no middle term. And one last very important thing is this is the difference of squares, so you should have subtraction. If you can find all those three parts, then you know how this will end up factoring. This will be x plus y and x minus y. For your perfect square trinomials, again, you want the first term and the last term to be squared. The last term over here should be positive. Now comes the tricky part. You want the middle term to be twice what you get when you multiply x and y together. And it doesn't matter if it's positive or negative since you have two different formulas for those, but that's what it should turn out to be. Now if you can recognize all of those things, then you know how these will break down. This one will be x plus y squared, and the other one will be x minus y squared. Now, be careful when using these quick and easy formulas. Note that there is no sum of squares formula. It's often very tempting to look at something like x squared plus y squared and think that it will break down, but be careful, it will not. So let's say, can't do that. Don't even try. So be very key on picking up these small things. That way you can save yourself some time when going through that factoring process. Let's give it a try. I want to go ahead and factor x squared minus 16 squared. So I think this looks like the difference of squares. Let me end up rewriting it a little bit so you can tell. So this is x squared minus, and I needed the other number to be squared as well. So this would have to be a 4 squared. So I'm looking at my two terms of being like an x and a 4. According to my formula, this will definitely factor. This will factor into x, then plus 4, minus 4. Now, let's go ahead and multiply things back together to see why this is really the correct factorization. If we take our first terms, we get x squared. Our outside would be minus 4x. inside plus 4x, and our last term's minus 16. So you notice that those outside and inside terms, one is positive, one is negative. Other than that, they're the same, so they will end up canceling each other out. So the only thing we're left with is just the x squared and the 16 like we should. So you can be pretty confident that this is the proper factorization when dealing with the difference of squares. The other ones that we want to look at are those perfect square trinomials. Let's see if we can hunt this one out. So I'm looking at it, I can see that my y is squared, and I want to write the 100 as being a squared number as well. So y squared plus 20y plus the number 10 squared. So my first term in there is a y being squared, and my last term is a 10 being squared. My last term is positive, that's a good sign. I need to check just one more thing. Is my middle term twice the first term multiplied by the last term? So 2 times y times 10. Well, it doesn't take too much work, but if we do multiply these together, maybe rearrange them first, you'll see that we do get a 20y like we're supposed to. So I can use my nice little shortcut formula to go ahead and factor this. My first terms will be y, and my last terms 10. And notice how y plus 10 and y plus 10, they're exactly the same. So we go ahead and we write this as a single term with just a square exponent on it. Nice, very quick and easy. Now let's go ahead and multiply this out to show you that it really does work. So my first terms would be a y squared. My outside and inside terms would be exactly the same. My last terms, 10 times 10, would be 100. The fact that our outside and inside terms are exactly the same means that we will have 2 of them. So that's why we need that 2 in our shortcut formula. All right, so that should make you pretty confident that this is the correct factorization for our perfect